All right, so for our first lecture, we're going to go ahead and review some things about functions. Now, my expectation is you've probably seen functions in previous math courses, but just in case you haven't, or just in case it's been a while, we're going to go ahead and this first week, the main focus is going to be on functions. So what is a function again? A function is a relationship between two or more variables. So you'll probably usually think of things such as y equals mx plus b. If you think about the equation for a line, or you might sometimes see f of x equals mx plus b. But these can be all sorts of things. They can relate things like distance traveled versus time. They can be things like velocity versus time. It can be the amount of salt dissolved in water versus temperature. And what do all these things have in common? Well, when we're looking at these, we're typically looking at two types of variables, our independent variable and our dependent variable. So for our independent variable, this is going to be the function input. And for our dependent variable, this is going to be the function output. I can't spell today. Hopefully that's not a trend this video. All right, so when we're looking at, say, this equation, f of x equals mx plus b, the function input then is going to be x. So this is our function input. And our function output is going to be that f of x. So what does that tell us then? Well, if I plug in, say, let's change this example up a little bit. Let's say f of x equals 2x plus 3. If I tell you x equals 3, then f of 3 would be 2 times 3 plus 3, so 6 plus 3, so 9. So the value of our independent variable is 3, and so the dependent variable, which what this ends up being depends on what we make our independent variable be, ends up being 9. So that's just a little bit of an example. All right, so when we're talking about functions, we have a couple of different terms we want to go ahead and make sure we understand with those: domain and range. So the domain is just the set of all valid input values, and our range is the set of all output values. So we'll talk a little more about these as we continue on to see some examples. Now we also can quickly tell by the graph of a function whether or not something, or whether the graph of something, if it's a function or not, through the vertical line tests. So for example, if we had two graphs and I had something that looked like this, if I tried to draw a vertical line through it, it'll pass more than 1 point. So this is not a function. However, if I had something that looked like this, no matter where I draw a vertical line, I will only get and intersect with 1 point. So this is a function. We don't necessarily know at the moment what it's a function of, but it's a function. So the vertical line test essentially formalizes this. It says a vertical line passing through each element of the domain can pass through only one range value. All right, so we can go ahead and try to make write our own functions. So let's say, as an example, we wanted to write a function that took a number, any number, multiplied it by 2 and subtracted 1. So when we see this any number here, we're going to think of x. So if we had some sort of function of x, f of x, what this function is doing is it's going to take x, we want to multiply it by 2, so let's make it 2x, and then subtract 1. So f of x would be 2x minus 1. We also have something known as piecewise functions. So piecewise functions are going to be a little bit different than, say, a standard function. Essentially, how piecewise functions work is they're going to be defined by different formulas for different portions of our x-axis. So, for example, let's say we wanted to graph these functions. So the first piecewise function we have is f of x equals x plus 1 when x is less than or equal to 1, and 3 when x is greater than 1. Okay, so if we wanted to graph x plus 1, what we'll do is we will think about what the values will be. So if my value is 1, since 1 is one of the values we care about, if I plug in 1 for x, that'll be 1 plus 1, and we'll get 2. So we should have the point 1, 2. And we should fill it in with a dot because we're using the equals portion. So because it can be equal to that value there, we'll have it as a filled in dot. And then from here, we just go ahead and continue this with values off to the left because we're looking at x values less than or equal to 1. So if we plugged in 0, 0 plus 1 is 1, so we get the point 0, 1. If we plug in negative 1, we'll get negative 1 plus 1 is 0. And this will keep happening. We'll get our line going this way. Now, when x is greater than 1, our value is going to be 3 for f of x for this piecewise function. So we go up to 1, 1, 2, 3. And because it's not actually equal to 3 at this point, we're going to go ahead and denote that with an open circle. So now we have the point 1, 3. And no matter what I have my x value as, once we're past 1, the y value or the f of x value is still going to be 3. So from that, we'll just go ahead, draw a horizontal line with 3. So here, if we talked about our domain, there are no values of x that were stopped from plugging in. No matter what I picked for x, even if it was 1, I could plug it into my function and get some sort of value. So the domain here would be negative infinity to infinity, and we put parentheses around that. Now, what about our range? So our range talks about our set of output values. So take a moment and see if you remember how to write this, because this is a little bit of a tricky one. Just take your moment. Great. Okay, so when we're looking at our range, we're looking at all the different f of x values or y values that we get from our independent variable or from our dependent variable. So if we continued this line going as far as we could get all the way to as far down as possible. So we're going to start at negative infinity. Now on this side of the line, we continue to go all the way until we get up to a y value of 2. And then we have a little bit of a gap. So we're going to go ahead and go to 2. And because we have this value included, we're going to put a square bracket. Now the next thing we have is we have this value of 3. And while it isn't here that we have a y value of 3, along this entire line we do. So here we would go ahead and include 3 with things. So the way to go ahead and say we just have 3, put a little set notation around just the value 3, like so. And then because we want to have both of these sets, we'll go ahead and use the union to join them together to be one. So that might be a little bit outside of our comfort zone, a little bit of our memory. That'll be practice with that sort of thing. All right, so now we'll go ahead and look at f of x equals the absolute value of x. But we're only going to look at the absolute value on certain parts of the interval. So now we're saying that we have f of x equals negative x between negative 2 and 0. So if we're looking at negative 2, notice that we do not include that. So if our x is negative 2, negative of negative 2 will be a positive 2. So we'll have our value there. And then we're just matching our negative x values to our x values as we go. And then we should have an open circle for this part at 0. When we look at the top part, we're just matching up to x. So we're going to go ahead, and when it's 0, it'll be 0, so we can fill this in. And then we'll match up to x the rest of the way and keep going with that. So when we look at our domain here, the lowest value we try to get to is negative 2. We don't include it though, so because we don't include it, we put a parenthesis. And then we can go as far as we want, so we can go all the way to infinity. So negative 2 to infinity. And when we're using infinities, you always put a parenthesis. As for the range, so these are the output values, these are the y values. Take a moment and see if you can get it. Okay, give you a moment. So the lowest value is going to be 0, and because of this, we actually include the 0, because of that top part. And because of this right side, and it keeps going up and up and up, and it'll go as high as our x values do, this is going to go all the way to infinity. So our range is going to be 0 to infinity. So this gets us then to talking about some special types of functions. So we already know about our domain, right? The domain of a function, f of x is the set of numbers x such that f of x is defined, and the range of a function f of x is the set of all values of f of x. So in other words, what all the outputs are. So we want to talk about specific types of functions that we'll be looking at. So first and foremost are polynomials. These are things I'm hoping we're most comfortable with. So these are things of the form f of x equals an x to the n plus all the way down to a1x plus a0. So the a sub i's are the numbers, and the n's are integers. So in other words, things like f of x equals 3x cubed plus 4x squared plus 2x plus 1, or something like f of x equals 5x squared minus 3. As long as they have integers for the exponents, we're talking about polynomials. The domain here, because we have nothing to worry about, is going to be all real numbers, negative infinity to infinity, or just the set of all real numbers, R. Then we also have rational functions. Rational functions are things of the form f of x equals gx over hx, where here g and h are polynomials. Now here, the domain is going to be all real numbers except for the denominator, h of x, is 0. So remember, one of the big things we can't do is we cannot divide by 0. That's going to be an issue for us with our domains. So if you ever want to divide by 0 with rational functions, that's a domain problem. So that's a thing we have to worry about. There are also root functions. So functions of the form f of x equals the square root of sub n x, where n is an integer. So for example, we could have f of x equals the cube root of x, or f of x equals just the square root of x, which is the same as writing a 2 there with the x. We also could have f of x equals fourth root of x. So all of these are possible for our different things that we could get for a root function. Now, when we're talking about the domain of a root function, remember that our biggest thing is we cannot take the square root of a negative number. So if we have an odd power here for our root, then we have a domain of negative infinity to infinity. And the reason for this is because when you're taking cube roots, fifth roots, it's possible that you raise a negative number to some power to get to this point. So it's okay to have negative numbers underneath the radical when you have an odd root. However, if your root is even, then we only can go from 0 to infinity. In other words, whatever's underneath the radical cannot be negative. Next, we have exponential functions. So these are things of the form f of x equals a to the x, where a is a number we call the base. So we can go ahead and say that we're taking some number and raising it to some power of x, or maybe some function that involves x. So, for example, f of x equals 3 to the x, or g of x equals e to the negative 2, or to the 2x minus 5. This might be a little bit. Maybe I should zoom in for you guys.